everyone. In this video, we'll see univariate data visualizations. As discussed in the previous video, can you recall what univariate analysis is? Univariate analysis is analysis of single variable, analysis of each field separately. This is called univariate analysis. And to do this, we'll consider one of the most popular datasets, which is iris dataset. This iris dataset contains three classes of 50 instances each, where each class refers to a type of iris plant. The different variables involved in the dataset are sepal length, sepal width, petal width, which are continuous, and variety, which is categorical variable. Though the dataset is multivariate in nature, for univariate analysis, we consider one variable of interest at a time. So first, we'll import the libraries and the dataset. First, we'll start here with the text cell, importing the libraries. We'll first import the pandas library, pandas as pd, and we'll import numpy as np. We'll run this, and now we'll import the dataset. Importing the dataset, we'll create a variable df equals to pd dot read csv iris dot csv, and to print the data frame we'll simply add df here and we'll run this. So you can see the data frame here. Here we have sepal length, sepal width, petal width and variety. First let's inspect the data types of the data variables. Then we can decide on the right methods for univariate data visualization. We simply have to do df dot d types. The .d types property is used to know the data types of the variables in the dataset. Pandas store these variables in different formats according to their type. They store categorical variables as objects and continuous variables are stored as int or float. The method used for visualization of univariate data also depends on types of data variables. We'll run this. So we can see here sepal length, sepal width are of float data type, that is they are continuous, and variety is object, that is categorical. Now let's import libraries essential for data visualization. Import matplotlib dot pyplot as plt and import tborn as sms. We'll run this. Okay. So let's see few methods to visualize univariate continuous data first. Visualizing univariate continuous data. And among them, the first one is univariate scatter plot. Scatter plot. This plots different observations or values of the same variable corresponding to the index or observation number. Let's plot for variable sepal length here. plt dot scatter df dot index df sepal length. and then plt.show. The plt.scatter function of matplotlib plots a univariate scatter diagram. The scatter function requires two parameters to plot. Here, we plot the variable sepal length against the corresponding observation number that is stored as the index of the data frame df.index. Let's run this. This is the scatter plot. Now let's visualize the same plot by considering its variety using sns.scatterplot function of the Seaborn library. sns.scatterplot x equals to df.index and y equals to df of sepal length and q parameter is df variety. In Seaborn, the hue parameter determines which column in the data frame should be used for color encoding. This helps to differentiate between the data values according to the categories they belong to. The hue parameter takes the grouping variable as its input, using which it will produce points with different colors. The variable passed on to this parameter can be either categorical or numeric, although the color mapping will behave differently in the latter case. Let's run this. This is the plot, and you can see that three classes are colored with three different colors here. And now let's see line plot. Line plot. Line plot visualizes data by connecting the data points via line segments. It is similar to a scatter plot, except that the measurement points are ordered typically by their x-axis values and joined with straight line segments. So let's plot this for petal length. So first, plt dot figure fig size equals to 5 comma 5. This is to set the size of the figure, and then we'll do plt dot title line plot of petal length. This is to set the title, and then plt dot x label, which is index font size equals to, we'll set this to some 15. This is to set labels on x axis, and then plt dot y label petal length. We'll also set the font size here equals to saying 15. This is to set the label on y-axis, and then plt dot plot df dot index df petal length, then mark every equals to 1, marker equals to d. The plt.plot function by default plots the data using a line plot. And then here we do for name, comma, group in df dot group by variety, plt.plot, group.index, comma, group petal.length. We'll set the labels. Label equals to name, comma, mark every equals to 1 and marker equals to D. Here, the df.groupBy function is to group the rows of the data frame according to the parameter passed onto the function. The groupBy function returns the data frames grouped by criteria variable passed and the criteria variable. The for loop is used to plot each data point according to its variety. Then we look plt.legend. This is outside the for loop. This adds a legend to the graph which describes the different elements seen in the graph. And then plt.show. This is to show the plot. The mark every parameter of the function plt.plot is assigned to 1, which means it will plot every first marker starting from the first data point. There are various marker styles which can be passed as a parameter to the function. We'll run this. So you can see a line plot of petal length with 3 different colors specifying 3 different classes here. You can do the same using sns.lineplot. sns.lineplot function can also visualize the line plot. Let's see sns.set rc equals to figure dot fig size. We'll set it to some 5,5 and sns.set font scale equals to 1.5 and fig equals to sns.lineplot x equals to df.index, comma, y equals to df petal length, comma, mark every equals to 1, marker equals to d, data equal to df, and the hue parameter is set to df variety. Now, fig.set x label equals to index. In Seaborn, the labels on the axis are automatically set based on columns that are passed for plotting. However, you can change it using the set function. We'll run this. See, here's the plot. Now let's see histograms. We'll add Excel histograms. Histograms are similar to bar charts which display the counts or relative frequencies of values falling in different class intervals or ranges. It displays the shape and spread of continuous sample data. It also helps us understand the skewness and kurtosis of distribution of the data. Now, plotting the histogram using the matplotlib plt.hist function, we simply have to do plt.hist, and the parameter we'll be passing is df petal width. Run this. See, here is the plot. The Seaborn function sns.distplot can also be used to plot a histogram. We'll see sns.distplot df petal width kde equals to false, color equals to black, and bins equals to 10. The KDE kernel density parameter is set to false so that only the histogram is viewed. The bins parameter indicates the number of bins in histogram allowed in the plot. We'll run this, and here is the plot. Now let's see density plots. We'll add it Excel, and the fourth one is density plots. A density plot is like a smoother version of a histogram. Generally, the kernel density estimate is used in density plots to show the probability density function of the variable. A continuous curve, which is the kernel, is drawn to generate a smooth density estimation for the whole data. Plotting density plot of the variable petal length here, plt dot figure. We already set the fixed size to be 5 comma 5, so no need to add the statement again. We'll simply do df petal dot length dot plot time equals to density. Let's run this. This is the density plot for petal length. You can do the same with seaborn. Simply sns dot kde plot df petal dot length, and we'll also add a shared parameter here, shared equal to true. Let's run this. See, this is the plot. By default, the kernel used is Gaussian, so this produces a Gaussian bell curve. And next we'll see box plots. Fifth one is box plots. A box plot is a very useful and standardized way of displaying the distribution of data based on 5 number summary, that is minimum, first quartile, second quartile, which is median, third quartile, and maximum. It helps in understanding these parameters of the distribution of data and is extremely helpful in detecting outliers. Plotting box plot of variable sepal width plt dot box plot df sepal width. We'll run this. See here, this is the outlier. This is the minimum value of the whole data we have. This is the lower quartile, This is the outlier, minimum value of the whole data, and this is the minimum. This is the first quartile, which is first quartile, or a lower quartile, which is 25th percentile. This is the median Q2. This is the upper quartile Q3, which is the 75th percentile. And this is the maximum. And these are the outliers again. And among these, this is the maximum value in the data. This is the interquartile range, that is between Q1 and Q3. This minimum can be calculated using the formula Q1 minus 1.5 into IQR, which is interquartile range. Similarly, the maximum can be calculated using Q3 plus 1.5 into IQR, interquartile range. Now let's plot box plots of all variables in one frame. But since the box plot is for continuous variables, firstly create a data frame without the column variety, that is, drop the column from the data frame using the drop function and specify access to 1 to indicate it. So we'll add df2 equals to df dot drop variety, and we'll set the access to 1. tlt dot figure. We already set the figure size, so it's okay. We'll directly go for the title, and the title is box plot of variables, and tlt dot box plot df2 dot values comma labels equals to sepal length, shortcut SL, then sepal width, then petal length, and then petal width. Let's run this. Here are the box plots of 4 variables. Now, plotting a box plot in Seaborn. SNS dot box plot df sepal width, and this, here it is. And plotting the box plots of all variables in one frame using Seaborn. SNS dot box plot x equals to variable, y equals to value, and data equals to td dot melt df2. Run this. Here it is. Now, univariate data visualization plots helps us comprehend the enumerative properties as well as the descriptive summary of particular data variable. These plots help in understanding the location or position of observation in the data variable, its distribution and dispersion. Univariate plots are of two types: enumerative plots and summary plots. Univariate enumerative plots are the plots which enumerate or show every observation in data and provide information about the distribution of observation on a single data. Examples of these plots are univariate scatter plot, line plot, strip plot, swarm plot, etc. Univariate summary plots. These plots give a more concise description of a location, dispersion, and distribution of a variable than a enumerative plot. It is not feasible to retrieve every individual data value in summary plot, but it helps in efficiently representing the whole data from which better conclusions can be made on the entire data set. Examples of these plots are histograms, density plots, rug plots, box plots, violin plots, etc. Now let's visualize categorical variables. We'll start here by adding a text cell, visualizing categorical variable. And among them, the first one we'll see is bar chart. Bar chart. The bar plot is a univariate data visualization plot on a two-dimensional axis. One axis is the category axis, indicating the category, while the second axis is the value axis that shows the numerical value of that category, indicating by length of the bar. So we'll start here df variety, and the categorical data in our data set is the variety dot value counts dot plot dot bar. The plot.bar function plots a bar plot of categorical variable. The value counts returns a series containing the counts of unique values in the variable. Run this. See, since the variety is equally distributed, as we discussed it in the beginning of the video itself, each 50 values, we obtain bars with equal heights. And the count plot function of Seaborn library obtains a similar bar plot. There is no need to separately calculate the count when using the sns.countplot function. And now let's see pie chart. Second one is pie chart. And a pie chart is the most common way used to visualize the numerical proportion occupied by each of the categories. So we'll see plt.pie df variety dot value counts value counts comma labels equals to setosa firstly hello spreadsheet. And we'll set the shadow to true. Here the plt.py function is used to plot a pie chart. Since the categories are equally distributed, it divides the sections in the pie chart equally. We add the labels by passing the array of values to the labels parameter here. Run this. Hmm. You can also do this in the following way. Like, let's create a new data frame df3 equals to df dot sample frac equals to 0.35. A random sample can be created using the data frame dot sample function. The frac parameter of a sample function indicates the fraction of access items to return. Then plt dot py df variety dot value counts, comma, start angle equals to 90, then auto PCT equals to percent point 3f, and we'll copy the same thing of labels and shadow. We'll paste it here. Labels and shadow are same. The start angle parameter of the pi function rotates everything counterclockwise at a specific angle. As the angle specified by us is 90, it rotates everything at 90 degrees angle. Further, default value for start angle is 0. The autopacity parameter enables one to display the percentage value using Python string formatting. Now run this. So this is the pie chart. Before going to the next video, make sure you complete the exercise, and in the next video, we'll see bivariate analysis. Thank you.